way back in 7th grade, children, on lesson number 69, we talked about, I'm going to go back and make sure that's where it's at. How many of you remember direct variation? Friend, can you tell me anything about direct variation? Because I'm going back. If you had a book, I'd have you go back and look, but since you don't, I'm going to. I want to see the exact, here it is. You are going to split your notes into 2 separate yet equal parts. Kind of like the Great Compromise. What was the Great Compromise?
So everyone's and they stuck them together. And then so they had a house based on population and they had a house based on
Variation. We've got 2 different types. Okay, we've got direct variation, which we've talked about way back halfway through your 7th grade year. And then what we're actually talking about today, which is, you'd like to think if there's direct, there's indirect, but it's not called indirect, it's called inverse variation. Okay. Direct variation, simply put, is kind of the logical thing that we usually think of, and the fact that as one thing goes up, the other thing goes up proportionately. Goes up proportionally. But for something to be direct variation, okay, there were 2 characteristics that it had to have, if you remember. Does anyone remember what they were? Okay, characteristics. If you saw a graph of this. The characteristics were, John, number 1.
Go through the origin.
Yep, it goes through the origin. And number 2, Jerry?
It had to be a straight line.
Okay, it's a straight line. Okay, had to be a straight line. As the book says, another way to think about it is it has to have a constant factor. An example of that would be when you're talking about the speed of a car. Okay, if a car is going 30 miles an hour, okay, the formula for that would be the distance a car goes is equal to 30 miles an hour times its time. If you were drawing a chart on that, where x is your time and d is your y, okay, if you went for 0 hours, how far would you go? 0 miles. If you drove for, your time was 3 hours, you would go 90 miles. If your time was 6 hours, you would go 180 miles. And if you were graphing that, the line of that would, in fact, start right here, and it would go, you know, something like this. It's a straight line going through the origin. And that was our direct variation. The equation, or the little, you know, math people like to throw in their whatever little things. This is what direct variation looks like. They would say, they would give you this, that k equals y divided by x. K equals y over x, where k is what we call a constant. And then in this case, 30 was the constant. 30 was the number that you used every time. The x's and the y's change, but the 30 does not. K equals yx. Y over x. Which, by the way, can you forget that this says this right here for a minute? If k equals y times x, what other equations could you make that are the same as that? Think about that for a second. Nick?
Y equals kx.
If you did the cross multiplying, y times 1 equals k times x. Those are the exact same things, and that's what we had here. Y equals k times x. So remember, this and this are direct variation because it's directly variated. Now, I'm going to move this over because that is not anything at all what we're talking about today. Ain't that ironic? Well, it is kind of, but why won't it let me do this? Anybody? Somebody help? Where can I put this?
In the garbage?
No, I don't want to
Up
throw it
there.
away. Here, I'll just
Top
make
right.
it really small. You still read
It
it?
looks like Chinese writing.
The little dots with these.
By the way, if you ever want to look at it again, I think I can probably blow it back up again, can't I?
Used to be a little zoom thing.
No, I can pull it back, can't I? Why won't it let me pull it back? See? Uh-huh. I go backwards.
Now that's Chinese.
Oh, I can't undo that. Is there an undo button? Oh, redo. Now, inverse variation, children, is opposite of that in the sense that it says, don't let me get it here, as one increases, the other decreases. As one increases, the other decreases. Now, can you think of something in this world where that happens? Nick?
When the temperature outside increases, the people outside decrease.
That would be a great example of. Now that it's hard to say that would be in proportion all the time, but that would be one form of it. Yes, John? As the supply goes up, the demand goes up, doesn't it? No, as the supply goes up, demand goes down because you have too much of it. That's true. Maybe in the terms of driving a car, children, the more miles you drive, the less gas you have, correct? The more you drive, the farther you drive, the smaller the amount of gas you have. What does the book say here? Anyways, we can do that forever. Here's the different equation using the same thing. For inverse variation, here is what it is. It is x times y equals k. Okay, instead of having it, where was it? Oh, okay, it's not this one over here. Instead of having it y divided by x, it's actually x times y gives you k. For example, and here would be the deal, just putting numbers in there, you write that down again, xy equals k. Let's say your constant was 8. Okay, say your constant was 8, whatever you were doing. If x equals 2, what would y? Let me do the little chart, x and y. If x was 2, what would y be? 4. If x is 1, what is y? 8. Notice how x went down, but y went up. If x is 0, what is y? Still going through that origin. If x is, if x was negative 2, y would be negative 4. Okay, did y went down, x went up? I'm not so sure we can use negative numbers with this, actually. And here is, let me give you something here. Where's it at? Well, write this down. Write this little problem down. Maybe this will make it a little clearer. Maybe it'll make it less clear. Whichever one you prefer. Trish travels 120 miles to visit a friend. Trish goes 120 miles to visit friend. Man. He averages 60 miles per hour. I guess it's a boy. He averages 60 miles per hour. If he averages, the trip takes how long? 2 hours. Okay. Now take a look at this. Let's make a table of this. Okay, where the x value is the rate, how fast he's going, and the y value is how long it takes him to go. Think about this. This is an example of inverse variation because we know, first of all, his rate was 60, he went 2 hours. What if his rate was slower? He went 40 miles an hour, then the trip is going to take how long?
3 hours.
3 hours. What if he was only going 30 miles an hour? It would take 4 hours. What if he was going 20 miles an hour? 6 hours. What if he was going 10 miles an hour? 12. What if he was going no miles an hour? It would take him 0 amount of time? You're right, it would be infinity. Now, let's take a look at the graph of this, children, because here's where you're going to go, wow, that is something. Ready? Through only the magic of the board, I need a little more room. Let's sketch the graph of this. If we sketch the graph of this sort of thing here, which one do you think, what should we make x? Time?
Rate.
What?
I think it should be rate.
Oh, I think maybe you're right. We usually make this the x and this the y. Fine. So instead of making each slash mark, let's go by tens, right? 10, 20, 30, 40, 50, 60. This is why we need block scheduling. And then going up, we're going to have the time, right? Where do we go all the way up to? 12 hours? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Let's look at the graph of this. Where is point 62? Right here, right? Where is 43? Right about here. Where is 34? Was that 3, 4? How about 26? 1, 2, 3, 4, 5, 6. And 10, 12. Now, what do you notice about the sketch of the graph of inverse variation, John?
Not a straight line.
Doesn't have to be a straight line. As a matter of fact, we will never ever get, we talked about this, if I put 0 in for x, okay, if I put 0 in for x, I will never ever get an answer. Okay, somebody said it would take forever to get there. If you're going 0 miles an hour, you're never going to get there. So this line here. But if you go 1 mile an hour, it's going to take you 120 hours. Think how high I'd have to draw that graph to get that thing there. Now, and same thing goes with going the other way here. How fast would I have to go to get there in 0 hours? No, that'd still take you an hour. Your 120 would be right here. Our next dot we could put on there would be right here. At 1 hour, it would take you a rate of 120 miles an hour. When will I ever get to this axis here? When will I get to 0 hours? How fast would I have to do to go 120 miles in 0 hours? You can't do it, because you'd have to be going faster than the speed of light, or whatever it would be. So this, when you graph this, it is going to look like this. This line is going to approach these axes, but it will never, ever, ever cross it. Now, mind you, you could get awful close. I could travel at 1 billion miles an hour, and I'm going to get right close to that 0 line, but I'll never get there. It's still going to take you a millisecond or some amount of time. Even at 1 billion miles an hour, there's no way you could ever make it. You could, unless you could be at the same place at the same time. 0 is never an option for time. Okay, never an option. Think about that. That's almost mind-boggling, isn't it, Nick? What's your question there, Nick?
Can it ever slope like back around or no? Like, can it go like this?
Huh?
Can it ever like slope?
No, but you could have, you can get a negative side of this. Okay, if you started using negative numbers, which gets a little goofy when you talk about rate, you know, if you were going negative 60 miles an hour, how much time would it take? -2. So you'd have to be over here at the -60, and you'd get -2. The graph is going to be identical. It's going to be like a mirror image. This line will make a mirror image of this line over here on this side. In other words, it'll look like this over on this side as well. But we can't travel 0 time and 0 miles, so this part is really not an option there. Jackson?
Before I throw, can I go positive then to negative? Like,
No. These lines will, there'll be no, there's no connection here ever between those two parts of that graph. Nick?
Well, what if he's going in reverse in a way? So would that be?
It doesn't matter. You can never go reverse distance. You can never go backwards distance. Distance is always a positive. That's what we talk about absolute value. You can, even if you're driving your car backwards, you're still going a positive distance.
No, but what if you're
You
trying
can
to
never go a distance in the hole.
get towards the destination? Like I was trying to get towards that chalkboard and I went like this.
Huh? But you're still going a positive distance.
But not towards the chalkboard.
Yeah, that's in relatively speaking. I'm gonna stop you because the question